GameStop, remember GameStop?
All right.
They all bought and then it became expensive.
So the rule for differentiating a quotient. If capital F at x equals f at x divided by g at x, and the derivative is found, and in this case, the order absolutely matters. So it has to be the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. So this is the order that you must follow when doing the quotient rule. We said with the product rule, it doesn't really matter which order you do it in because you're adding the product of the term and the derivative of the other term. But in this case, because you're subtracting, order absolutely matters. So it has to be the derivative of the top first times the bottom. Okay, so looking at this first one. Now, yesterday we also saw that in many cases when you have a product, you could multiply them out, simplify first, differentiate after. In this case, you normally can't do that because you might have the urge to say, okay, well, and don't copy this part down, but let's say that you wanted to divide both terms on top by the 3x on the bottom. So this is what it would look like. You'd have 2x over 3x plus 1 over 3x. Okay? So that would leave us with 2 over 3 plus, and then what we would normally do is make the 1 over 3x all to the power negative 1. That's what you would do. Because remember, in order to differentiate, you have to have terms expressed as a power, and then you use that power rule. But here's the problem. Because it's just not x to the negative 1, it's 3x all to the negative 1, we would have to differentiate that term using the next rule we're going to learn, which is called the chain rule, and that's the rule that you use when you have an expression other than just x raised to a power. This is 3x all raised to the power negative 1, not just x. So to differentiate from there, you'd have to know about the chain rule, which is the next thing we learned about. So therefore, in most cases, you're not going to be able to simplify before you differentiate. So we'll differentiate these using the rule that's at the top, which again, derivative of the top times the bottom is what you do first. So f prime x equals derivative of the bottom, which will just be 2 times the bottom, minus derivative of the bottom, which is just 3 times the entire top, all over the bottom squared. So you're squaring the entire bottom. And now it's just a matter of simplifying. We'll get 6x minus 6x minus 3 over 3x all squared, which we could write as 9x squared. The 6x's cancel, and you'll get negative 3 over 9x squared, or negative 1 over 3x squared. And so there's the derivative. Okay, question 2. To differentiate, we will use the quotient rule, derivative of the top times the bottom, minus derivative of the bottom, which is 3x squared, times the top, all over the bottom squared. And make sure you're aware that you cannot cancel that x cubed minus 1 on top with one of them on the bottom, because the top is a binomial. There's two terms there. If you're going to start canceling expressions like this, you have to be able to cancel the same thing in all the terms. And you cannot, because there's only one factor of x cubed minus 1 on top. There isn't one in both terms. So, again, we go to simplifying, multiplying it out. And then 2x to the fourth minus 3x to the fourth is negative 1x to the power 4. Then we have a minus 3x squared and a minus 2x. Okay? Number 3. We'll do this using the quotient rule. Once again, derivative of the top times the bottom minus the derivative of the bottom, which is a binomial in this case, 3x squared plus 1 times the top, x squared plus 1, all over the bottom squared. Derivative of the top times the bottom minus derivative of the bottom times the top, all over the bottom squared. So, multiplying out, you're going to get 2x to the fourth plus 2x squared. Now, with that minus sign there, we're going to have to multiply out those binomials. We'll simplify, and then we'll subtract that whole expression. So I'm keeping the brackets there to remind ourselves we're going to have a negative in front of the bracket. So when we remove the brackets, all those signs will change. The front terms will be 3x to the fourth. The outer terms will be 3x squared. The inner terms, positive 1x squared. That gives us positive 4x squared. And then the last terms, 1 times 1 is 1. And so now when we simplify, you're going to have 2x to the fourth minus 3x to the fourth. That'll be negative 1x to the fourth. You're going to have 2x squared minus 4x squared, which is minus 2x squared. And then you're going to have negative 1. And in some cases, you can do some simplifying further. And to see that, we would have to square out the denominator. So we'll get negative x to the fourth minus 2x squared minus 1 over. When you square a binomial, remember, you square the first term. You multiply the two terms together and double. When you multiply these two terms together, you'll get x to the fourth. Doubled is positive 2x to the fourth. And when you square the last term, you're going to get positive x squared. And now the denominator has a common factor. Okay. So I've got negative x to the fourth minus 2x squared minus 1 over. If you take out a common factor of x squared, that will give you positive x to the fourth, positive 2x squared, and positive 1. Which is the negative of what's above. Exactly the same three terms as what's above. The only difference is that all the signs are different. So had I taken out a negative x squared instead of a positive, then it would have looked exactly the same as what's above. But it doesn't matter. You don't have to do that. You should recognize that the numerator is the opposite of that second factor in the denominator, so you can still cancel them, and you're left with -1 when you do that. And so you'll get -1 over x squared. There's the final simplified answer. Now, this one could have been done by simplifying first. And so it's not a bad idea to kind of look at the expression before you just jump into using the quotient rule. Because if you look at the denominator, there's a common factor of x there, right? And if you take out a common factor of x, you're going to get x squared plus 1 inside the brackets, which is the same as what's above. This one can be simplified first. So as an alternate method, and it's going to be much easier, we're going to see, if you again factor out a common factor of x on the bottom, you'll get a factor of x squared plus 1 there, and that will cancel with the x squared plus 1 on top, which leaves us with 1 over x, or x to the -1, which we would now differentiate by using that power rule that we saw yesterday. It would be -1 x to the -2, or -1 over x squared. Much simpler. So the moral of the story is, look at the expression. You should be able to look at that denominator, realize that there's a common factor of x there. Realize that if you take it out, you're going to be left with x squared plus 1, which is the same as the top. Right? And so this also only works because the denominator works out to be just x, which is x to the -1. Had there been a coefficient in front of that x, in brackets to the power -1, well, then you couldn't do it that way yet, because we haven't learned about the chain rule. But in this case, you didn't need to use a chain rule because it was only x to the -1. All right? So looking at number 4, there's no factors. Well, there is a factor for the top, I think, x plus 3, x minus 1, but that doesn't help us for the bottom. Okay? The denominator is a sum of cubes, but the first factor would be x plus 1, not x minus 1. So there's nothing we can do here to simplify this, so we'll go straight to the quotient rule. And because the original expression is y equals, we would express the derivative as dy by dx. Derivative of y with respect to x. So derivative of the top times the bottom minus the derivative of the bottom times the entire top. All over the bottom squared. So again, we'll multiply out the top. And simplify. So I got 2x to the fourth, take away 3x to the fourth. That gives us -1x to the fourth. I have a 2x cubed minus 6x cubed. That's -4x cubed. I've got a 9x squared, positive 2x, and a positive 2. and there's nothing more that we can do. Like, there's no common factor of x on top. If we square out the bottom, you will get an x to the 6th term. You'll get a positive 2x cubed and a positive 1. There's nothing we can do with that either to help us simplify. Right? So that one is done. Number 5, remember, we've always written terms as powers. So that would be the first thing we would do here. Root of x is x to the 1/2 over 1 plus 2x. That's what y equals. So dy by dx, the derivative of y with respect to x, is the derivative of the top times the bottom minus derivative of the bottom times the top all over the bottom squared. So if we multiply these out, we'll get 1/2 x to the negative 1/2. And then when you multiply the 1/2 times the 2, it'll be positive 1x to the positive 1/2 minus 2x to the positive 1/2. There are like terms on top. There are 2 terms with x to the power 1/2, so we can combine those. If you have 1 and you take away 2, you're left with minus 1 of those. And there's a couple things that we can do to simplify this a bit more. One of them being the fact that we have a denominator in the numerator. We have got that 1/2 in the numerator. So normally we would multiply all the terms by the common denominator, which in this case would be 2. So the first term multiplied by 2 cancels with the 2 on the bottom. You'll just have 1x to the negative 1/2. The second term multiplied by 2, and the bottom multiplied by 2. The other thing that you might do here is take out a common factor on top. You've got one term with x to the negative 1/2, the second term with x to the positive 1/2. Remember, when you're taking out common factors involving rational exponents, you always take out the smallest rational exponent. Negative 1/2 is smaller than positive 1/2. So if we take out a common factor of x to the negative 1/2, that'll leave us with 1 minus 2x. And now we can take the factor of x to the negative 1/2 that's on top, and we can move it down to the bottom, and that'll make that exponent positive. So you're just going to have 1 minus 2x on top, and on the bottom we would have positive x to the 1/2, which would be root of x times the 2 times the 1 plus 2x all squared. And the last thing that, again, you might see happen is normally we don't leave answers with radicals in the denominator. So if we multiply top and bottom by root x, It'll be root x on top times 1 minus 2x over 2x bracket 1 plus 2x all squared. Okay, so again, technically, you get to that step there, you've taken the derivative. But if you're checking answers in the book, they may take it further, right? So you need to be aware of that. So we've seen that one of the applications of the derivatives is finding the slope of a tangent line at any point along that curve. So we want to find the equation of the tangent line to that graph at the point where x equals 3. Before we start, we know that we have to find the y value. We need to know the entire point of tangency. Whether you're using point slope form or slope intercept form, you need to know the x and the y. So let's start there. Okay. So y would be found by letting x equal 3 in the equation. So 3 squared is 9 times 2 is 18 minus 9 all over 3 squared is 9, take away 4 is 5. So that gives us 9 on 5. So our point of tangency is a point 3 comma 9/5. So now we will find the derivative. And the quotient rule again tells us it's the derivative of the top times the bottom. And before we do that, if you look at the original expression, you'd recognize that the denominator's difference of squares, x plus 2, x minus 2. If you take out a common factor of x on top, you're going to get 2x minus 3. So that's not going to help us. It's always a good idea to make that check real quick to see if you can simplify the original expression a little bit. But in this case, we can't. So we took the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. So if we multiply out the brackets, you're going to get 4x cubed. The outer products will be negative 16x. The inner product's negative 3x squared. And the last term is plus 12. The 4x cubes are going to cancel. So we're left with negative 3x squared plus 6x squared is positive 3x squared, and minus 16x, plus 12. And there's an expression for the derivative in simplest form. And we can use this to find the derivative, the slope of the tangent, by letting x equal 3. 3 squared is 9, times 3 is 27, minus 16 times 3 is 48, plus 2. 3 squared is 9, take away 4 is 5, squared is 25.
Would that be plus 5?
I don't know, I'll play your little game, is it? Yep, you are right.
Plus 2? I'm not right. What?
Thank you.
It's part of the Oh, it's part of the chain rule. We don't understand.
Yeah, you don't understand that a 12 just becomes a 2 for no reason. Maybe one day you guys will get there, but you're not ready.
We're not at the higher level of math.
Right.
Numbers don't equal themselves.
Right. So 27 and 12 is 39, excuse me, minus 48 is negative 9 over 25. So that's the slope of the tangent. And now we can find the equation. And in this case, if I just decide to use y equals mx plus b, the x and the y are the numbers at the point of tangency, which y was 9/5. M is negative 9 over 25 times x, which is 3, plus b. So we can solve for b. So you'll have 9 over 5 equals negative 27 over 25 plus b. If we add the 27 over 25 to both sides, we would need to write 9/5 with a denominator of 25. And we get that by multiplying bottom and top by 5. So it'll be 45 over 25 plus 27 over 25. So that's 72 over 25. So our equation will be y equals negative 9 over 25 x plus 72 over 25. That's the equation in slope-intercept form. If you want it in general form, you can't have any denominators, so we'd start there by multiplying everything by 25. And then move everything over to one side, make it equal to 0 on the other, and normally the x term is positive, which means I'm going to take the two terms to the right and move them to the left by adding 9x to both sides and subtracting 72. So there's the equation in general or standard form. So I said at the start of the course, there's often lots of algebra that you're going to have to do. Right? So you need to be prepared for that, because there's lots of algebra in this course. So you should be working on these questions, but those last two assignments, remember, are due for marks. So you should be getting those done and handed in, at least one of them today, because you're a couple days behind if you haven't finished those off. Okay, so those last two assignments I said I'm taking for marks. So it'd be a good idea maybe to get working on those today so that you can at least get one of them handed in today. Not today, but we will. Yeah, very soon. Okay.